excited to have everybody here today. It's a big honor for us. Our goal is to have a conversation about AI and its impact on supply chain. So that's a big topic. It's also a rapidly moving topic. And because of the importance of the topic, the three of us here founded AI4supplychain.org, a partnership between the University of Washington and D-House US, a global AI, machine learning, and analytics company. Our overall vision for AI4supplychain.org is to unite supply chain leaders, tech innovators, and academics in transforming supply chain challenges into opportunities through the power of AI. So we're very fortunate to have two incredibly accomplished people helping to lead the discussion today. Both are our co-founders at AI4 Supply Chain. So the main presenter today is Fabio Federetto, CEO of D-House US and a member of the board of advisors at the UW SCTL program. Fabio is the former head of Accenture's AI and analytics group throughout Latin America, a practice encompassing over 400 professionals and serving some of the largest companies in the world. He holds both master's and bachelor's degrees in logistics, systems engineering, and construction engineering from the University of Sao Paulo. We're also joined by Professor Amelia Regan, director of the UW SCTL program and teaching professor at the UW's prestigious School of Civil and Environmental Engineering. Amelia is a widely published author and is an emeritus professor and co-founder of the University of California, Irvine's Professional Master of Computer Science program. She's also a faculty member of UCI's master and PhD degrees in transportation. Her research focuses on the development of computational methods to improve the efficiency, sustainability, and security of transportation. She also serves on the board of advisors of companies exploring warehouse automation and robotics. She holds a bachelor's degree in systems engineering from the University of Pennsylvania, a master's in applied mathematics from Johns Hopkins University, and a PhD in transportation systems from the University of Texas. Just as importantly, these are two very personable people and very approachable people. So what I thought we would do is start off with Fabio giving us an overview of one of the AI applications he developed for a global materials company. We'd then like to turn to Amelia, get some of her comments, and then start working through some of the questions that you submitted ahead of time, and also feel free to ask questions in the chat. Just for timing purposes, let's hold any questions for the discussion. So with that, let's turn things over to Fabio. And hey, Fabio, as I was getting ready for this, I put into Bard, hey, give me a couple of sentences about the importance of AI, right? And this is what it kicked out. It said, quote, "From demand forecasting to inventory management to transportation optimization, AI is transforming every aspect of the supply chain," which is a pretty blanket statement. But the first one it kicked out, demand forecasting, rumor has it, it's something that you and your team know a little bit about, right? So with that, why don't we turn it over to you? Appreciate you both being here today. And let's hear a little bit more about the work you've been doing with your clients.
Hi, thanks, Dan, for the intro. Actually, we know a little bit about that. So we've been probably working with demand forecasting, inventory planning, and optimization for, I don't know, maybe 15 years in our careers, right? And since we started the house 2.5 years ago, we still keep doing it with our clients, right? So the thing that I can tell you is that, so we can't be afraid of AI being used into those specific topics, because in my optimistic point of view, it's here for bringing us accuracy, more visibility, and it's enabling us to be much more proactive in terms of decision taking, those types of business challenges that we typically have to overcome in supply chain, right? So guys, I'm very happy to meet you virtually here, right? Very happy to actually be able to speak a little bit about a success story that we developed here in Brazil. I was planning to actually intro myself and the company, but Dan already did that, so I'm going to skip that up. I'm going to share the screen with you guys. Just let me know if you are actually seeing my screen. Are you? All right, perfect. Okay. So I'm skipping that. I just want you to know that the House is a company founded by senior executives with very extensive experience in analytics, business technology. We have probably in our story about 300 different projects that we did with some of the largest companies around Americas and Europe. And right now we have a team of approx 50 guys spread out between US, Brazil, and Europe. So we are covering 12 different time zones. Actually, I took that KPI as a successful one because we can serve different clients in different geographies, right? And actually, I'm here to tell you a story, right? A story that illustrates how we use the AI and embedded AI within one of the most critical supply chain decisions in the business, which is to change or to adjust production plan to cover for potential future stock out. So I'm sure that everyone here that handles with supply chain in a daily basis faced that scenario probably once in our lifetime. And probably you guys are going to identify yourselves with that challenge, right? So to give you a little bit more about the context, right? So this case actually happened in Saint-Gobain, Brazilian operations. I don't know if everybody knows that company. For the ones who doesn't know, they are the leaders in light and sustainable construction, actually producing and distributing materials for construction and industrial markets. And it's actually almost a startup. It's actually founded in 1666 under the reign of Louis XIV. And I'm telling you that because we also face in different and typically, like, let's say, older companies, some mindsets that technology might not help a lot, but these guys, apart from the fact that they have 350 years of story, they are very open to new technologies, new approaches, right? So that story actually starts during the pandemic, right? So during the pandemic, they faced extreme demand volatility, mainly due to the fact that people, when pandemic just hit us here in Brazil, that people started working from home. It happened all globally, right? And what happened is that they realized that their home offices were not good enough. Their homes they want to do some home improvements, and then they started increasing the demand. Actually, the demand already started to increase for materials for construction, right? So the problem that they faced is that they had very limited warehouse space for keeping an adequate safety stock. They were actually literally were choosing what products they would not produce, and consequently what products they were accepting to lose sales. This is what they were facing at that time, right? On the right side of the slide, you can take a look, the curves, right? So the orders are in purple. So you can see the fluctuations, the volatility there, right? And also on the black curve, you can see the stock out, and it's ramping up as the pandemic is hitting, right? And then after understanding that problem, so we dig a little bit deeper, right? So we take a deep look into their different DCs and different SKUs, and we realized that the problem was not in 1, 2, or 3 different lines of products, for example. It was actually spread out. spread out, hitting almost all the DCs and hitting for sure all product categories. Obviously, the impact was not equal into every single combination of DC SKU, but it was happening in all their supply chain. So something had to be done, right? So we discussed it together with the client, and this is something that's very important before taking one analytical action into place, right? Is to have a good scoping discussion with the client, right? So we understood with them that they already had a structure and established SNOP running for years, right? So it was not actually a question of having a flawed planning process or that typical inexistence of planning culture that we see in some of our clients, right? So we realized that we should move forward and focus on the short term, right? So the topic that came to the table was their scheduling and their execution was underperforming, and it was not as robust as it should be to actually face that amount of demand volatility, right? So what we did, so we came with the idea to try to get visibility into their short-term stock out potential, and with that, we could flexibilize a little their production orders with the objective to cover up for that probable future stock out risk, right? As soon as we defined that scope, we came out with the solution, right? So the solution to do that, we actually defined only two major components. So the first one was a scalable data structure that would capture in-house data from different data sources and ensure that it would be clean and available to be used, right? The scalability criteria was very, very important because since the beginning of the project, Saint-Gobain had the aim to roll out this to other products and even to other geographies, right? So the second component of the solution was actually a stock out prediction algorithm that we based that in a machine learning to define whether or not it would be a stock out for any given combination of DC SKU for the next 2 weeks. So that was the main business challenge that we want to address with the use of AI, right? So the method, right? We based on our approach, let's say, in kind of a typical machine learning development methodology, right? But we added some tweaks to it, and I'll give you some insight on that, right? So to explain a little bit about the method, so it all starts with ideation, right? So we put all the bright minds to the table to understand the business problem, translate that business problem into an analytical problem, and then maybe define 2 or 3 different scenarios to actually solve that analytical problem. And to do that is not only putting a lot of data scientists to the table, we have to put guys that understand the business, guys that understand the data, guys that understand the operational execution of the problem, of the process that we are studying. So it's actually a multi-profile team of people that will be working together for some sessions and to in the end ideate what would be the solution for that, right? From that, we derived into the variables that we would need to feed the model. So this is still on the ideation phase, which lead us to different data sources that would have to be captured. So those data sources were the priorities to actually being captured to feed later into the model, right? From that, it's pretty straightforward. So we gather the data, clean it, ensure that it will be ready. It would be ready to be used. Then, after capturing that data, we started doing some feature engineering, which combine different variables to define different let's say, features, right, that we would add to the AI model and increase its probability of explaining the phenomena that we wanted to explain in a better way, right? Then after doing feature engineering, I'll give you more details on that in the following slides. The engineering team builds the data pipelines to ensure that running the model will be feasible after testing and go live. And to close it, the science team typically refines the model, tweak the model, and measure its performance, right? So I want to enter in some of those steps for you to take a look on how we translated the business challenge into the analytical challenge and how we actually tried to mimic the supply chain dynamic within the model to actually come with the right decisions, right? So on the ideation, so you can take a look. This slide is an illustration of the discussion that we had about the different variables, right? So you can take a look that we covered practically the whole Saint-Gobain supply chain. We approached that into every single echelon of the supply chain. So we started in the factory, understood and how it worked, and then try to identify variables that were related to raw materials, packaging, the production lead times, then go into inventory, try to mimic the stock policy, try to get levels of inventory by each DC, then go to the demand, transportation, characteristics of the production when they have like excess of inventory or when they have promotions, and that would lead to different production mix. Other scenarios for underproduction, defects, and many other stuff that are actually not here. It's not an exhaustive list, but gives you a picture that that one thing that is very, very important in the ideation phase is we need to try to be as exhaustive as possible, that we ensure that there is not a very relevant variable that is left behind, okay? Then from those variables, we started discussing the model, right? So when we do modeling ideation, it's not only a matter of what should be considered, but also how it will be used in the real life. You can see the execution characteristics that we had to consider to develop it and to run it in the best possible window, for example. So on the right side of the slide, you can take a look on the parameters that we had to take into consideration in order to select the best technique and the best maybe window to run that the algorithm in the daily basis, in the daily life of the company. All those things should be taken into consideration when we are actually ideating the model, right? Also, and then when we were ideating that model, one thing that came to the table was the lead time, right? So it was not only a matter of what are the variables or what were the variables that should be considered, but also a matter of the time window for each decision within supply chain. And I'll give you an example. When we plan a production, for example, we already are typically counting on availability of raw materials, right? But that availability only occurs because someone in the past decided to actually buy them, right? So we had to actually model this problem into a two deep dimension fashion. One that considered what were the variables within each decision, and the other that considered the time in the past that every decision was made. With that approach, we could mimic the lead time dynamic of every single decision in the supply chain, and that was what made the model very adherent to mimic their operational execution, right? So with all those things, crazy things in mind, let's say something like that, we went to feature engineering, right? Which is the combination of different variables to enhance the way the machine learning algorithm classify the problem, right? So typically, one typical thing of machine learning models is that the classification technique is a classification technique. It tries to classify if something is going or is not going to happen, if something is positive or something is negative, for example. This is a way of some machine learning models actually work, right? So as much problem-related data we insert into the model, the probability of it classifying correctly the phenomena that we are trying to determine improves a lot. So, for example, we did not only use past 1 week stockout data to forecast future. We did actually pass stockout for 1 week, for 2 weeks, for 3 weeks, and so on. The same happened with demand forecast, on-hand orders, and so on and so forth. So in the end, we transformed one single variable, which was like past stockout for 1 week, but we started to add stockout for 2 weeks, for 3 weeks, for 4 weeks, and that produced different new variables that we could then consider them as features and then fed this into the model, right? So moving from a lot of technical things to more business things, so you can take a look, right? So instead of explaining a lot of the technique that we use it, I really want to see you guys to see the results, right? So you can take a look. This slide actually tries to sum up a little bit of the results that we got. On the left side of the slide, you can see the potential risk of stockout that was predicted by the model in a specific DC, right? So you can notice that there were not a lot of SKUs with high risk, right? Only 3 there, above 50%, right? But the tail of the curve is huge, right? So you can take a look that a long part of their product portfolio had medium to low risk of suffering, right? So that also brought to the table that the importance of that type of solution and how they should put that solution go live and roll out to other parts of the business, right? On the right side of the slide, you can see the different metrics for the different models, and that goes a little bit back into some technical things, but I want to show you that it's important to notice here the F1 score, right? Why? Because stock count is typically a rare event, right? And the F1 score is a metric that balances false positives and false negatives. And in our case, it was solid at 0.67. It goes from 0 to 1. So we're kind of 70% there, which is pretty good for that scenario that we face it, right? We also focused on the higher supply chain resilience, which in your case was to have more false positive, meaning that we were predicting more stockouts than what would actually happen. Why? Because when we predict a little bit more of the stockouts that would actually have, we are planning the production for a higher level of demand volatility. In that case, the business scenario will be much safer. Probably some inventory would be overstock, but it would be safer and would ensure that the client would not lose a lot of sales, right? To close, guys, in terms of business results, right? So in the end of the day, we got over 80% of accuracy predicting future stockout events for the top 5 warehouses of Saint-Gobain in Brazil, right? With that AI performance, they were able to change their production scheduling and cover for that stockout risk. It was massive for them at that time, right? But then with the time of the COVID thing slowing down, the dynamics changed. But what didn't change the relevance of this solution, right? So the question that comes is, are they still using it? The answer, yes. They actually took the model and rolled it out to other DCs and products in their Brazilian operation. And now we know that they are discussing to scale this solution into new geographies, right? So this is a very, very nice news to hear when after we deliver one project, right? Guys, you can have my contacts there. Feel free to reach out to me. But I would like to open for any questions you might have regarding the case. The idea here was to show you how an AI model and that kind of tech solution could be applied into a real daily life business challenge, and how we use that to actually mimic the dynamic of their supply chain.
Amelia?
So rather than a question, I'm just gonna start with a comment. Fabio, what I really liked about your talk is that, yes, it's a concrete case study, but you provided some very general steps of analysis that would be done in many, many related kinds of problems and questions. So that's a very valuable way of laying out this kind of work. Since we don't have direct questions right now from the audience, I'm going to go ahead with a few comments I have to make, and then we got some advanced questions, and we'll talk about a few of those, and then we're hoping that the audience will come back with many other kinds of questions. So so the primary use of AI and machine learning in supply chains is really the use that's been happening over the last decade. And even before that, we use statistical modeling, which is just a precursor to machine learning tools. And that's in forecasting of all sorts of supply and demand across supply chains. So we can think of supply of truckloads to make movements in the future, supply of maritime transportation, space and air cargo operations, rail operations, and then, of course, as Fabio was talking about, of stockouts. When a distributor has products to sell, how can that distributor know when the products are going to be stocking out, or when he has too many, and so on. So lots of interesting questions for forecasting in all aspects of inventory and transportation and other supply chains. But right now, so some changes that have happened in the last few years is that some of these forecasting functions are being directly integrated into optimization models. So the play between optimization modeling and machine learning and artificial intelligence is very important, and there's just been tremendous increase in the last few years in those kinds of things. For example, order batching and sequencing in warehouse operations, mainly fulfillment operations, is very important. So the best kind of order batching and sequencing we can have for the hundreds and thousands of orders that come into warehouses in a single day has a huge impact on how well we can fulfill those orders. Ways to increase efficiency, reduce congestion in the warehouses, reduce manpower, and so on. And then we're explicitly adding AI and machine learning tools into large-scale optimization models in order to reduce processing time. So we're taking very complex optimization models, and no, they're not being. This is a question that came up. We're not replacing sort of routing and scheduling optimization models with AI and machine learning, but we're improving the performance of those optimization models by including machine learning in certain steps. So that's some of the most exciting things going on. Everybody in the last year has been wanting to talk about generative AI. What is going to be the impact of generative AI in supply chain systems and increasing the efficiency of supply chain systems? And I don't believe there's going to be an instantaneous transformation, but I do believe that many aspects of our jobs as managers and as analysts will become more efficient in the next few years as we integrate certain aspects of large language models, of generative AI into our workforce and workplace operations. So many companies are multinational, and although we have language experts on the ground in different areas of operation, there's translations that need to be done. Generative AI will achieve the goal that AI has said it was going to achieve for the last 40 years, which is solid translation. It makes it much easier for us to master statistical or computer languages, because it makes it easier to express what we want to be done in human language and then translate that into, say, Python or R. Eventually, we will be able to translate codes that we write in Python and R that are rather simple into C++, for example, a much more efficient kind of code. Those things are not perfected yet, but they will be important and increasingly available to us in the future. So it will make us much more efficient. And then, of course, all sorts of applications in sourcing and procurement. So, you know, some of the questions, you know, really wanted to know, are there concrete ways that AI is improving supply chain operations now? And indeed it is. And then, you know, another question that I wanted to address is, if AI is combined with automated robots, because we're going to have robots in many different kinds of operations, will it impact the workforce? And I think the answer to that is very slowly, right? The grave statements about that we won't need any truck drivers, we won't need warehouse workers, and so on has never happened and won't happen soon. But many of the most dangerous jobs will be able to be phased out, and so that we can focus on the jobs that perhaps take more intellectual work rather than just strength. Okay, those are just a few of the comments I wanted to make. I have more if we have time, but let's see if there's some other questions that we need to address.
So, Amelia, I'm trying to address some of the questions on the chat already, but feel free, okay?
Yeah, and feel free to talk about them to the group. So Adam asked if it was AI or ML. You gave an answer, but what's the rough explanation there, Fabio?
So it's a machine learning algorithm, Adam, that was focused on classifying whether or not a product would face stockout in the following 2 weeks. This is the technical, let's say something like that. We can go deeper into technical things, but probably that was it, right? AA is asking about AI in collaboration. So my view in collaboration is pretty straightforward, right? So typically, the company starts asking sales guys, marketing guys to fill templates, to fill Excel files, so on and so forth, right? To actually grab data from that would represent the sales guy's sentiment from the field. I try to, when we develop some things to actually overcome that challenge, we try to bring some tech components to get their life easier in terms of feeding us with data. So I believe a lot in tech automation for that. I saw some cases in different companies here in Brazil. Also, what we are seeing right now is that combination between public data and private data. So we are working right now into that specific field for a pharma company. And we are acquiring data from government organizations, from marketing industry in the field to actually see on the drugstores what prescription, for example, the patient is actually feeling. It's kind of different in Brazil because the way that drugs are sold here is completely different from America, but anyway. And then bring to the table to try to integrate that data, run some analysis, and bring more insights to the table. So that's more or less what I believe, right? So feel free to contact me if you want. We can discuss. I can show you a little bit with more details what we did.
Okay, Fabio, real fast. Rodrigo asked, what other key business applications can AI help with?
Within supply chain, I'm seeing a lot in terms of facility location, a lot in inventory optimization, a lot in fleet, so routing, a lot of different challenges we see inside supply chain. Outside, I'm seeing a lot in terms of CRM, mindset, customer mindset, journeys, a lot of different things, right?
So Rishikesh asks, how does AI in supply chain precisely identify and proactively address disruptions by analyzing vast data sets, predicting potential issues, and recommending real-time solutions?
Amelia, do you want to address that, or?
I guess you take a shot at it. I'm not sure I understand exactly what the question is asking, right?
It's like how AI can, so I can take that. Just want to not be a monologue here, but right. So right now, what we see is like the performance of different algorithms are improved a lot, right? So the limits that we faced, let's say 3-4 years ago, are completely gone, right? So now we are processing really vast amounts of data to try to be a much more to have much more granular insights to the table. So I think the main difference, Rishikesh, from what we saw in the past is, I don't know, maybe some years ago we were discussing impacts for forecasting into category of products into a channel. Now we are discussing insights regarding a specific SKU in a specific shelf of a store. So this is the type of different approach that we actually can take right now. Is a lot more bottom up insights than top down insights. That's I think it's the key.
Yeah. And maybe one more. Adams asked, can the model account for seasonality and fluctuations?
Yes, for sure. So when we add, for example, the demand pattern on the case that I just showed you, we add it daily, weekly, monthly, and then by combining those different variables of demand, when we were doing feature engineering of the project, we then were able to consider or take into account seasonality, fluctuations, and sometimes even some demand drivers. For example, I remember a model that we developed about five or 6 years ago that were highly dependent on lightning. And I don't know if you guys know, but Brazil is the #1 country in the world in terms of lightning, right? So we started the project thinking of, okay, the demand will be driven by rain. So, but then we realized it was not by rain, it was about lightning. So we developed a model and used that variable as a feature to actually explain the phenomena better. Completely different industry from Saint-Gobain, so it's a crazy different case, but anyway.
Yeah, great. Okay, how about one more question? Anybody else have another question? Then we'll wrap up and let people get on with their. Can users adjust the forecasting model in your software, or is it fixed and only changeable by administrators?
So that solution that we develop for Saint-Gobain is actually not a software that we own, right? So we develop it for the client, and they can tweak the model using the software that we developed for them, right? But I can give you a different answer to that, right? So when we develop a software that has so advanced technique embedded in, right? We need to take into consideration that on the other side of the table, there are going to be data scientists using that, but probably they're going to be the demand planner that only is used to work with Excel in a much more simpler way of doing things analytically. So if we develop a software to do that and would sell into a lot of different companies, we will probably have two different approaches, one for a more sophisticated or deep skilled professional that knows AI, knows the parameters, can do hyperparameters and so on, and for others that don't know a lot about that and can only tweak certain things of the model.
Perfect. Okay, great. So gang, I wanted to say thank you for joining us today. We were really excited to see how many people were interested in this topic. You know, like I said, it is a big topic and it's a fast moving topic. We'd really like to hear your opinions. You know, our idea today was just to open the discussion. So we'd like to keep the discussion going. If you'd like to go on to the AI4 Supply Chain AI for the number 4sc.org website and give us some ideas, right? This is considered to just be the first of many fireside chats. So if you've got particular topics you'd like to see us address, drop us a note on that. The other thing that I'd like to throw out is we're going to be doing a series of lunch and learns, right? So you've got, just pull together people in your organization. And if there's a particular topic that you want us to do a deep dive in, if there's a topic that your organization is struggling with, let us know. We're very fortunate to have access to a huge panel of industry experts and luminaries, data scientists, academics who can put something together pretty quickly for you. We're thinking those things will probably be, 20 minutes of presentations and 20 minutes of discussion. So pretty light lifting. And the thing that's interesting about the lunch and learns is, just the fact that you're here today listening to this shows that you're interested, but maybe other people in your group need to have their awareness level raised a little bit. Maybe you have a boss who you're hoping to sort of pull into the AI world. A lunch and learn is a great way to do that. So if you'd like to go on to the website, just drop us a note. We'll be in touch and we'll figure out a time. Those would be all online. Figure out a time to get those done. So again, thank you, Fabio and Amelia, for being here. And of course, Katie, who is always working silently but tirelessly behind the scene to pull this off and make it seem so easy. We really appreciate everybody coming today. And like you said, if you had a technical question on Fabio's case study, feel free to follow up. Feel free to send a message to Amelia or any one of us. So thanks, gang. Have a great day, and let's hope that you'll join us for our next one. Amelia, do you want to say anything else?
I just want to say we have the UW Supply Chain Transportation and Logistics Program has a number of these fireside chats on all sorts of topics scheduled for the next year. So we'll be announcing those in the future, just to keep us in mind. And thanks very much for coming today.
All right. Have a good day, everybody.
Thank you, guys.
Thank you.